Okay, everyone, welcome to this quiz preview. Make sure that you are taking good notes and you're watching and following along this video carefully so you can do well on your quiz. All right. So number one here is a spinner problem, right? So let us highlight the important information, of this problem. So it says there is a spinner that with 12 equal parts numbered 1 through 12. If the spinner is spun one time, what is the probability the result that the result is a multiple of 3 or a multiple of 4, right? The key word here being or, right? So this is an or problem. So the total number of chances we know is 12, right? Because it's a spinner of 12 equal areas. Our multiples of 3 and 4. Our multiples of 3 are 6, 9, 12. And our multiples of 4 are 4, 8, 12. Notice not going beyond 12 because 12 is total chances. And since this is an or problem, we have combined. So we've combined 3, 6, 9, 12, 3, 6, 9, 12, and 4 and 8, 4 and 8. Now, we don't need to write 12 again because 12 is already here, right? So we don't write 12 again. So how many numbers is this in total? So we have 1, 2, 3, 4, 5, 6 out of 12. So our probability will be 6 out of 12. Or if I reduce by 6, I get 1 over 2. So either one of these two would be a solution for number 1, which is an or problem, right? So we combined all the multiples. All right, number 2 is an and problem, as you can see here. So I'm going to point that out when we go over the notes here. There is a spinner with 15 equal areas, number 1 through 15. If the spinner is spun one time, what is the probability that the result is a multiple of 5 and a multiple of 2? Emphasis on the word and. This is why this is an and problem. So once again, we see that the total number of chances are 15 because 15 equal areas in the spinner. Our multiples are our multiples of 5 and 2. So our multiples of 5 are 5, 10, 15. Once again, be sure not to go past 15. And our multiples of 2 are 2, 4, 6, 8, 10, 12, 14. Not passing 15. So what number do they have alike, right? What number is on both lists, on that list and on that list? Well, we can see here that it is 10, right? 10 is the number they have alike. So which number do they have alike? 10. How many numbers do they have alike? 1. So our solution will be 1 out of 15 total areas. And that's our probability, 1 out of 15, that we get in a spinner of 15 equal spaces, that we have a multiple of 5 and 2. And 2. All right. Number 3. Let's see. In a certain Algebra 2 class of 20 students, okay, 12 of them play basketball, okay, 13 of them play baseball, and 3 students play neither sport, okay? So what is the probability that a student chosen randomly from the class plays basketball or baseball? Okay, plays basketball or baseball. So as you can see here, I filled in all the information that I got. Total of 20 students. 12 of total played basketball, 13 total play baseball, and 3 play neither sport. Make sure that you draw your table here, 4 by 4, right? From here, we are going to fill in our missing numbers, right? Our missing numbers. So remember, in order to find the missing boxes, we subtract the 2 boxes that we have. So 20 minus 13 is 7. So to find this missing box, I'm going to do 20 minus 12, which is 8. To find this missing box, I'm going to do 8 minus 3, which is 5. To find that missing box, I'm going to do 7 minus 3, which is 4. And to find this missing box, I can either go 12 minus 4 or 13 minus 5, which is in both cases 8. All right? So, which players play basketball? How many students play basketball or baseball? Right? Or baseball. So, we look at our selections here. Well, how many play basketball? Well, 12 play basketball, right? But let me tell you, I'm going to highlight them individually. So basketball are 8 and 4, right? And how many play baseball? Well, baseball is these boxes here, but 8 has already been highlighted, so I don't need to highlight 8, so I'm going to highlight 5. So these 3 numbers together represent how many people play basketball and baseball. So it is 8 plus 4 plus 5, which equals 17. So our probability is going to be 17 out of a total of students of 20. So this is our probability, 17 out of 20. Right? Now this was an OR problem, right? As you can see here, this is an OR problem with sports, right? So this is an OR problem with sports. Number 4 is another sports problem, but this is an AND sports problem. So let us highlight here. In a certain Algebra 2 class of 21 students, right? 6 of them play baseball. Okay. 10 of them play baseball. 6 of them play basketball. Right? 10 play baseball. And 7 students play neither sport. Right? So, what is the probability that a student chosen randomly from the class plays basketball and baseball, right? And baseball. So once again, I've made my table here, 4 by 4, right? Basketball, no baseball, and totals. Okay, so total of 21 students, total of 6 play basketball, total of 10 play baseball, total of 10 play baseball. 7 students don't play either sport, no basketball, no baseball. So once again, let us find our missing numbers, and we do that by subtracting the 2 boxes that we have. 21 minus 10 is 11. 21 minus 6 is 15. 11 minus 7 is 4. 6 minus 4 is 2. 10 minus 2 is 8. All right. So the question is, how many students play basketball and baseball? So this is an and, right? So basketball and baseball. It's these 2 right here. Right? So our probability is basketball and baseball are 2. So our probability will be 2 out of a total of 21 students. There you go. That's what a problem like that would look like. Okay. Number 5, right? Let's highlight our information once again. Okay. Let's see. In a class of students, the following data table summarizes how many students passed the test and completed the homework due the day of the test. What is the probability that a student chosen randomly from the class? Okay, this is what we need. What is the probability from the class passed the test, right? And completed the homework. So all I did was recopy this table here, right? 4 by 4. And now all I have to do is fill in the totals, right? I need to find the totals. Where the totals, I add these two. I add the two pieces of information that I have. 11 plus 2 is 13. 3 plus 5 is 8. 11 plus 3 is 14. 2 plus 5 is 7. And 14 plus 7 is 21. 13 plus 8, good, 21. Okay. So how many students, it says, what is the probability that the student chosen randomly from the class passes the test and completes the homework, right? Passes the test and completes the homework. That's 11. 11, right? So pass the test and complete the homework. So our probability is 11 out of how many total students? 21. So 11 out of 21. Okay. All right. Number 6. Same idea, right? So what is the probability that a student chosen randomly from the class does not have a brother? Does not have a brother. Okay. So again, I did my table here, right? 4 by 4. Brother, no brother. Sister, no sister. And I'm going to add to find our totals. 3 plus 10 is 13. 8 plus 6 is 14. 14 plus 13 is 27. That's good. 10 plus 6 is 16. And 3 plus 8 is 11. So, what is the probability that a student chosen randomly from the class does not have a brother? Does not have a brother. Well, how many total students don't have a brother? 16, right? 16 students don't have a brother. Out of how many total? 27. So the probability in this question is 16 out of 27, or 16 over 27. Okay. Number 7. So number 7 is a little bit more specific here, right? So in a class of students, the following data table summarizes how many students play an instrument or a sport. So it says, what is the probability that a student who plays a sport, student who plays a sport. So let's see. Student who plays a sport. So also, this is a different color now, also plays an instrument. Okay, so let's take a look. Let's fill in our data. Again, my 4 by 4 table, you're going to add to fill in our charts, right? 2 plus 4 is 6, 9 plus 3 is 12, 6 plus 12 is 18, 4 plus 3 is 7, 2 plus 9 is 11. So, what is our first condition here, kiddos? What is the probability that a student who plays a sport, so students that play sports are a total of 6, right? Well, what is condition number 2? Who plays an instrument? Plays an instrument. From this box here, how many play an instrument? 2, right? So condition number 1 was sports. which was total of 6. Condition number 2 was instrument, which was 2. So probability is C2, or condition 1, over condition 2, which was 2 divided by 6. Or if we reduce, we get 1 over 3. Right? There you go. This would be the solution for a problem like this. Be careful. Be careful with these types of problems that say the probability that a student who plays a sport. See, it doesn't say from the whole class. It's who plays a sport. That's why this was the bottom. This was condition 1. A student who plays a sport, a total number of students who play sports are 6. Okay? Number 8. Okay? Let us do number 8 here. In a class, what is the probability that on a student who has a cat, okay, a student who has a cat, given, this is the key, the tricky wording here, that they do not have a dog. Given that they do not have a dog. So this is a given problem. This is a given problem. So first thing I'm going to do is I'm going to fill in my chart, my 4x4 chart. All right. So cat, no cat, dog, no dog, total and total. 7 plus 3 is 10. 5 plus 9 is 14. 10 plus 14 is 24. 3 plus 9 is 12. And 7 plus 5 is 12. So let us see what our first condition is. Our first condition is, what is the probability that a student has a cat? But it says given there. That given, kiddos, is going to make the second condition actually our first. So given that they do not have a dog. They do not have a dog. So that's going to be our first condition. No dog. And how many total have no dog? Total? 14 don't have a dog. Right? So that is our first condition. No dog. And that is 14 people. Okay? Now our second condition is actually the first one that came up. What is the probability that the student has a cat? Right? Student has a cat. So has a cat. So from this box here, how many have a cat? 5 have a cat. So cat was a total of 5. So condition 2 over condition 1, 5 over 14. And that is our probability. Right? So be careful with these that say given, right? You got to flip the conditions. Okay, finally, last two, number 9. We're very familiar with these. So this should be a piece of cake, right? So if a resident who has a master's degree is chosen at random, so somebody who has a master's degree, so how many people have a master's degree? How many total? 24, 18, right? What is the probability that they are aged 30 to 49? Well, 30 to 49, kiddos, is both of these right here. So 30 to 49 are both of these right here. So in this box, right, which ones are 30 to 49? These two, right? So it's like that. So we're going to add those two. So our first condition was the purple, which is master's degree, right? Master's, which was 2,418. Then it was ages 30 to 49, people ages 30 to 49, which was equal to 640 plus 294, right? 640 plus 294, which I'm not sure what it is. So let us use our scientific calculator. All right, there we are. So this was 640 plus 294. 40 plus 294 was 934, right? 934. So condition 2 is 934 over condition 1, which is 2418. And when I divide those two, 934 divided by 2418. Okay, we're going to round to the nearest thousand, so I'm going to copy 4 numbers after the decimal, 3862. 0.3862. And our 6 is in the thousands place. So the 2 is going to tell the 6 to rest. 4 or less, let it rest. So it's 386. And that is our probability right there. All right. Finally, the last type of problem you might see here. So let us find our, let's see, our conditions. If an adult is chosen randomly from the town, okay? So from the town, total of 15,518, okay? What is the probability that they have a high school degree or some college degree, right? A high school only or some college. Well, from this box here is 4286 and 6313. 4286 and 6313, right? So our condition number 1 was total in the town, right? So the town had 15,518 people. Condition 2 was high school and some college, which was 4286 plus 6313. So 4286 plus 6313. So let's use 4286 plus 6313 was 10599. So this gave us a total of 10599. Well, our probability is condition 2 over condition 1. 10599 divided by 15518. And that gave us, let's see, 1055599. Oops. 10599 divided by, what is it? 15518. 15518. 0.6830. 6830. 0.6830. Our 3 is in the thousands place. The 0 is going to tell the 3 to let it rest. 4 or less, let it rest. So our solution is 0.6830. And there you are, kiddos. These are the type of problems you're going to see in the quiz. Make sure you pause and rewind and watch these videos to help you on your quiz. All right. If you have any questions, please raise your hand to clarify, right? I cannot explain how to do it, but we can clarify. All right.